listeners. Welcome once again to our podcast, The African Data Scientist, where we get to tell the story of the African AI and data science potential. And this week's guest is an amazing person. I think you get to know about him later. The program is called Insights in AI and Data Science. We have 2 episodes in the library. So you could check episode 1, where we had a conversation with Evangelist Michael, a data and intelligence engineer at Indichina, a fintech. So if you're all about AI in fintech, data science and fintech for African countries and startups, you can check that one out. And even more recently, we had a conversation, an interview, a very interesting one with Jeremiah Faduga, who is a teaching assistant at the African Masters in Machine Intelligence program. He also offered very cool advice and best practices for researchers and people looking to get jobs in data science and for Africa and in Africa, by the way. But this week's guest is Robert John. Robert is the chief data scientist at Versus and is also the first machine learning Google developer expert in machine learning for sub-Saharan Africa, and is also GDE for cloud technologies. We are so excited to have Robert here today, and let's get right into the session. Okay, welcome, Robert. Hi.
Thank you.
Yeah, thanks once again for coming and honoring our invitation. We are really, really excited about this, and even more excited about your session that will be coming up with her on our YouTube channel. Yeah. So, Robert, please, we want to get to know you. Can you start by maybe introducing yourself? But let's start from there.
Okay, so thank you for inviting me to this session. My name is Robert John, and I work as a data scientist for a product called Versus. And Versus is a consumer insights product. What we do is something called social listening, but for African data. And what that is our clients tell us what to look out for on their behalf on the internet. And when we get that, we provide them with a dashboard where we tell them what the sentiment is around what is being said. So Versus is a data science product. When I started out, we didn't have data science, or maybe it was, but in maybe some parts of the world. But that was about 2 decades ago. So I started out in the field of software engineering. Eventually, I got to start working with databases, and it was something that I found that I enjoyed doing because it didn't involve building user interfaces for anybody. So I was able to avoid all of the make this button larger, make this thing green or yellow, I don't like the colors. A lot of time that gets wasted on UI products. Instead, I just got to deal with data, the right stored procedures that other software engineers would interface with. And I found that was the kind of job that I enjoyed doing. Over the years, I built more software products, this time around interfacing them with databases. And I couldn't have imagined that I would end up working strictly with data, but that's what eventually happened. When I went back to working with data, it wasn't specifically for data science. I was essentially researching machine learning models that would provide some unique advantage to a product that I was trying to build at that point in time. To cut a long story short, I didn't build the product because I got too involved with the machine learning and data science side of things, and I never looked back. So that's me in a nutshell.
Okay, awesome. Thank you so much for that. So, talking about your background, what was that like? Did you have anything in mind? Specifically, you wanted to study data science, going into the university, or how was that journey like for you?
No. So back then, I got into university in 1998. I do not recall having seen any university curriculum that had data science listed there. Even things like information technology weren't courses back then. So back then, you either went in for computer science or you went in for computer engineering on the computing side. And then, of course, we had the other statistics, mathematics, physics, chemistry, all of those things. So while I liked computers back then, I had a preference of subjects. My favorite subjects were chemistry, physics, and mathematics, kind of in that order. But a career in either chemistry or physics didn't fancy me. I didn't want to do something strictly theoretical, but I also didn't want to do anything that was going to get my hands dirty. So things like chemical engineering, were completely out of the question. Things like electrical engineering were out of the question. So in looking at a curriculum, I found out that if I liked math, I could go for computer science. And I felt, well, why not? So I chose computer science.
All right. I think it's, of course, it's evident in your love for mathematics, because that background is such an amazing one, especially to transition you into your computer science space. But generally, of course, computer science, you said you didn't start off with software engineering, but was there a specific spark, or were there moments of spark that spurred your interest in data science, AI field? What was that like? Was there any specific event that really did that?
Yeah, so the specific event was quite recent, although even in my formative years, my favorite mathematics subject was actually linear algebra. So matrices was something that I could particularly relate with, regardless of the dimension of the matrices at that point in time. It was what I enjoyed doing. Fast forward to, say, the last 5 years or so, I was trying to build a product. It was an agricultural marketplace. And if you're conversant with the problems of Nigeria, it's the fact that those who are in the agricultural field are largely uneducated. And so what that means is they're not going to be communicating in English. So if you went to a farm in a place like Sokoto, for instance, you would expect the people there to speak Hausa. And if you went to a farm in Kebbi, you'd also expect them to speak Hausa. Now, agriculture has a large value chain. A lot of people look at agriculture simply as the cultivation of the product, but you have things like having to purchase inputs. Inputs are fertilizer or seeds or chemicals. You have post-harvest, you have the need to make use of a warehouse or the need for logistics. And then there's, of course, the selling component. So you could have someone from Lagos trying to purchase something from someone in Sokoto. The person in Lagos who's trying to make the purchase might not speak English, and the person he's trying to purchase from also doesn't speak English. So there's a need to have a language component. And so that need translates into some complexities. For instance, how do you get someone who doesn't speak English to tell you that he has got, say, 500 bags of beans that he's harvested and he needs a warehouse to store those until he gets buyers? Clearly, you're not going to be building a mobile app. What farmer uses a smartphone? So that leaves you with the choice of having them either make a phone call or send an SMS. In English, it's easy to say send an SMS in this structure. The first word should be this, the second word should be this, the third word should be this. But when you get to local languages, it becomes difficult. So if they're going to communicate, they need to communicate in local language. And then, you need to parse that local language. And so that need led me into the field of natural language processing and natural language understanding, where you need to receive inputs in some natural format, extract intents and extract entities from those, and do some sort of processing. And along the line, you might even find yourself having to do some sort of language translation. So that was the point at which I went off in that direction and never came back.
Never came back. So that's an amazing job. What was that? What did you end up? Did the product end up getting launched? What was the journey for the product?
No, so the product didn't get launched because I was essentially the only one working on it. And the field of machine learning is so large that you can't train machine learning models and also do software engineering at the same time. So I left that and focused on the machine learning side of things.
Okay, awesome. All right, thank you so much. That's a really, really introduction. But going back to your role at Versus as a chief data scientist, what do you specifically do as a chief data scientist? Because I think that's a job description. People would love to know how it works and stuff.
Okay, so when I got involved with Versus, because I'm not the founder, they had already spent 2 years with an idea. They had done some UI prototyping that they were using to market to potential clients, but there wasn't a product. The options that they had involved making use of Google's sentiment engine, Google's natural language API, but that is strictly for English language, so it doesn't particularly work well for African data. But even that wasn't built out. So when I got involved, I had to, I started by training some models. And I mean, if you know data science, you know that the first problem is data.
Of course.
Clearly, because there wasn't a product, there wasn't even any data. And I had to make a judgment call. Should I go in and start fetching data and spend the next 3 months fetching data and labeling data? Or who am I even going to get to label the data? Data scientists do not label data. So I just made a judgment call and I used one of the academic data sets and I trained an initial model. And I was hoping that we would hit the ground running with the initial model because there were some some software engineers that were there that were going to build out the rest of the product. But I eventually ended up having to get involved with the software engineering side of things. But again, because I have, this long background in software engineering, it wasn't really a problem. I think it was more of a surprise for people than anything else because they thought that coming in as a data scientist means you have no idea, when people are talking about front end or back end or anything, right? But I ended up getting involved with building the product itself, deploying the machine learning models, setting up the Google Cloud Platform infrastructure to allow for storing and retrieving data, as well as setting up things like, the web deployments for the user interface, and a few other things. So what is data science at Versus like? Well, it's about solving the common data science problems. First of all, explaining to all stakeholders what exactly is going on, because there's usually a whole lot of confusion about what is going on. On one end, are people who think that, everything is either just magic or just a fluke. On the other end, are people who think that everything must be interpretable. And again, that's one of the challenges in data science, right? So you have, where people aren't actually training models, but they're talking about things like model explainability or bias or ethical AI and things like that. So that's really it. Yeah, explaining to stakeholders, making specifications about fetching data, ensuring that data gets labeled correctly so that models can be retrained and put into production and a better quality product can be shipped.
Okay, awesome. Now, is that generally a problem? The problems that you think that you face, that of course that you face in Versus, is it generally a problem you think other African startups, companies looking to employ data science face? Is it you think it's the same problem or there's a common problem between them?
Yeah, so I do believe that it's a common problem. Case in point is there was a time maybe last year or 2 years ago where almost every bank was trying to predict churn or trying to predict fraud or trying to predict some other financial thing. And when you look at the data, you just feel, hey, like these people do not have a complete understanding of what the data should look like. So yeah, I think that for most African data scientists, it's probably different in research. In research, I mean, you control everything. You decide what you want to research, and you go and worry about your data. Data is a huge problem in Africa, wherever you are. But in industry, it's even the stakeholders understanding what the data should be. So a lot of the time, there's no data, there's insufficient data, there's a general misunderstanding of what the data should look like as well.
Yeah. Well, okay, awesome. A quick one for our listeners. So what would be your advice to anybody going to be a chief data scientist, just like you at the company? What would be the advice to them? They're starting out their career and they're looking to, become chief data scientist someday. What would you advise them?
So that's difficult to say really, because it's like saying, if you're a medical doctor, how do you become the chief medical director at a hospital? I think it's, first of all, you have to be sure that it's something that you want to do long term. You do not graduate into a senior role in 2 or 3 years. I think people have that delusion about, the field of computing, because you see people just starting out and saying, so how do I become the boss? It's not like the startup space where once you're the founder, you're the boss. For computing, you need to put in time. You need to put in lots and lots of time. Usually you might have done that work for maybe 10 years, maybe not even starting out in data science, but in other fields. But you should have had extensive experience, because being at the C level in any corporation requires both operational and managerial knowledge. So, for instance, what makes someone a chief technology officer is not just the ability to write software, but it's also the ability to manage other software engineers as well as software processes. So without an understanding of software processes, you find out that you can't be, the chief technology officer. So it's the same thing with data science. It's not just I know how to fetch data and I know how to transform data side of things. It's also about understanding the data science process in depth.
Oh, awesome. I think that's a great take from you. And if you're looking to become a chief data scientist, it's not 5 years, probably about 10 years of your career, which makes a lot of sense. All right, so we are going now to the next set of our questions, and this is the questions are more machine learning and career related, just generally best practices and tips for data scientists and ML engineers out there. Robert, there's the particularly unique question we ask most of our guests on the show, and it goes like this. So pretend I'm not a tech person or a data scientist. Can you explain data science and machine learning in simple terms, and how those technologies aid problem solving in very simple terms?
Right. So I like to use analogies a lot. And my particular analogy for data science is to say, think of it like the field of biology. So data science is just like biological sciences, where biology is the study of life, data science is the study of data. So it's an end-to-end process where you have to look at the data and extract insights from the data. You need to be able to explain those insights that you've extracted and then learn to make predictions based on the patterns that you've identified from the insights. That's really the long and short of it. However, it's more complicated than biology in the sense that data science does not stand alone. There's usually what is called domain expertise. So what that means is data science in a medical setting is not the same thing as medical data science in an aerospace setting, for instance, or data science in an engineering setting, or data science in a financial setting. So you need to understand the industry for which you're going to carry out the data science, as well as understand the data science process. And it's usually easier going from the industry to data science than going from data science to the industry. So what that means is this: it's pretty difficult to take someone like me who has spent 20 years in the computing field and then try to teach me medicine and then get me to be a good data scientist in the medical sphere. It's a whole lot easier to get someone who started out in medicine but who has an interest in computing to then become a data scientist and then go back and work in the medical field. So data science, to start off, is really a process that involves taking the data from an organization, finding a problem statement, which is to say, we have this data. What can this data tell us about our business? And then once you found out what the data can tell you about your business, you then answer the next question. So can we make predictions about future demand or something else in the future for this business, giving all of the historical data and information that we have? So if you were to apply that to the medical field, for instance, let's take X-rays as an example. In the past, people have always used X-rays to try and detect, let's say, maybe tuberculosis in the chest or something in the lungs. And so you're able to say, looking at all of these X-rays, we can tell you which X-rays had, this pulmonary infection or this respiratory infection, and which ones did not have it. So, given all of this history, can we then take an X-ray and quickly determine who has one of these diseases? Traditionally, we would use humans, but perhaps we now have such a volume that using humans is no longer practical. Using humans creates a backlog where you get an X-ray and then you have to wait a few days for a specialist to come and interpret the X-ray. But can we have a computer where as soon as you take the X-ray, it's able to do that interpretation for you? That really is the field of data science, and a subfield inside of it is machine learning. So what I just described is, again, machine learning. So, you have some sort of maybe overlaps, unless we go into extensive details. But yeah, so that machine learning part is where we're saying, so if we gave you all of the historical samples of X-rays that we've taken in the past, can you tell us whether or not a new X-ray image has an infection? So that's data science and machine learning.
Oh, all right. Okay, thank you so much for such insight. And talking about discussing the field of machine learning and data science, coming back to the field of machine learning, of course, what's one thing about data science and machine learning? Of course, as a chief data scientist, part of your role, a major part of your role is working with people and working with its team. So what's one thing about data science and machine learning that you think is clear to you, but is not really so to other people, whether they are engineers or non-engineers alike? What's one thing that you think is clear to you?
So I'd probably say the fact that it's an extremely scientific process, but on the outside, people think it is either trial and error or luck, or sometimes they just say, isn't it simply statistics?
We heard that one. We hear it often.
Yeah.
All right. Coming back to your role in the industry, having worked with small and large companies, I guess, of course, you would probably have worked in the fintech space and working with Vasos now. How would you advise a small company to adopt an AI strategy in Africa, in developing countries like Nigeria, Rwanda, Kenya, and pretty much the African ecosystem? How would you advise small companies starting out and looking to employ data science and all of those? How would you advise them to adopt an AI strategy, and what would they do to be successful at AI and data science, in your opinion?
So I think that it's a bit more complicated than that. The reason being that data science is largely dependent on data. As a small company, do you have sufficient data to implement data science? So one of the things is, I'll probably say the first step should be understanding the data science methodology, because that understanding lets you then evaluate to say, are we at the point where we have sufficient data to utilize this, or should we outsource what we need? And again, I will give you an example. So if you are in e-commerce, for instance, let's take a marketplace as an example. So a marketplace is an e-commerce site that doesn't sell its own products, but utilizes third-party sellers who will upload their products and make them available to buyers. Now, in the very early days, you'll probably have some curators or some quality control officers who will look at every post and approve it. However, when you start to scale out, you will have so many people putting up things on a daily basis that you have two options. One is to just employ a really large workforce, and the other one is to employ some sort of automation. And so this is the point at which you would then start to say, okay, is this the point where we need AI? Now, let's say, for instance, that in making placements, these merchants also upload photographs. Now, let's take the simple case where your marketplace is for selling phones. These phones could be used or they could be new. But because you're a marketplace for selling phones, you don't want people selling knives on your marketplace. So how do you know when someone uploads the image of a knife so that you can automatically decline that?
Yeah.
So yeah, this is a valid place where you say, what would your data science or AI strategy be? Now, you probably do not have the capabilities to start training your own model to detect whether or not there's a knife in any image, or there's any dangerous weapon in any image. Or in fact, let's put it the other way around. You do not have the capabilities to train a model that says there is no phone in this image, and the only thing we want in an image is a phone, or there's a phone, but there's something else. So at this point, the strategy would probably be to outsource your data science and machine learning. And so by outsourcing, what I mean is to make use of some APIs that are provided by the bigger companies. So Google has what it calls a Cloud Vision API that will solve that problem for you. So that's when you're starting out. However, again, when you're starting out, if your problem is completely different, for instance, if your problem is building some sort of blood kit that detects a certain maybe African specific disease from blood, maybe that connects to a mobile phone, it's not something that you're going to be able to outsource. But then do you have the data? So a knowledge of the data science process would then tell you that while you have to build your own model, you're going to have to invest a lot of time and resources in collecting sufficient data that will let you train and deploy your own model. And of course, this model is going to be proprietary to you. So it's not something that is available to the general public.
Okay, awesome. Thank you so much for that insight. Now, back to you, back to your career. I think this will be very, very good for people starting out in the space. So, talents who are willing to improve, skill up in the field of data science and ML. So, what were the challenges? What were the kinds of types of challenges you faced while starting out? You know, you came in from the software engineering background and right into the data background and AI background. And what were the challenges you faced personally, and how did you overcome them while you were starting out?
So I think the biggest challenge was really having guidance, and guidance in the sense of saying, here's what you should learn first, and here's what you should learn next, or here are the options, which one do you prefer, and go off and learn it. So it turns out that I had to learn a whole lot of things, and it takes time for things to resolve, to start to make sense in your head when you're learning them. There are a lot of resources. I think that another challenge is also knowing what resources are good and what resources are not so good, or to put it differently, what resources are good for beginners and what resources are good for advanced individuals. So to put things in context, data science is a practical field. There are a lot of subfields in data science. Data engineering is what we could call a subfield because it deals with data acquisition, data storage, data retrieval, which is still part of data science. You know, when you need data, you go to the data engineer to get the data. We have data analytics and data visualization as subfields as well. And then we have machine learning engineering as subfields. So all of these exist, but all of these are practical fields. None of them is theoretical. In learning, you need to get practice. So there are certain resources that ensure that you get practice. And because you're getting practice, they also ensure that you build a curriculum that you're able to use to demonstrate to potential employers that you have the sufficient practice. However, there are some resources that do not require you to practice. And so people fall into that trap of consuming these resources but not practicing. Case in point is, if you were to go to YouTube, you'd find a lot of resources on data science. But because you can passively watch a YouTube video for 2 hours and not do anything, they're not resources that are targeted towards beginners. They're more often resources that are targeted towards advanced people, or at least intermediate individuals. Because when you go to search for those resources, it's because you have a particular problem, and when you watch them, you then start to solve that problem. But for instance, if I wanted to be a data analyst and I didn't know anything about data analysis, going to YouTube wouldn't be the right move. Instead, it would be going to a course that requires me to do some sort of assessment and assignments and get graded, whether it's automatic grading or manual grading, something that provides me with mentors that ensure that I stay on track. So that's my advice for like those challenges and
All right.
independence.
All right, awesome. Yeah, so back to you interfacing and working with a team of ML engineers or data scientists. What do you think are really what qualities generally do you think are the most important for people and someone looking to become a very good machine learning engineer, a data scientist? What are the most important qualities or skills you think the person might want to or need to possess for being a very good data scientist or ML engineer?
Right. So, first of all, you need to be a good software engineer. So, machine learning engineering entails software engineering. People sometimes assume that if I don't know how to write a simple function, I can successfully train a model because, it's not software engineering, it's called machine learning engineering. But that's not correct. So software engineering is a very important skill to have. Secondly, being inquisitive is an important skill to have, which is just the ability to ask questions from different directions. So it looks like you're solving a simple problem, but you need to ask more questions than would normally be asked by the average individual in order for you to solve that problem. Thirdly, it's tenacity. While in software engineering, you might say, oh, this thing usually takes 2 weeks to program. Machine learning engineering is not that way. You're not writing a whole lot of code, but you're going to be training for extended periods of time. You're going to be trying to improve your model accuracy, and that requires perseverance. That requires some sort of persistence. I think that those three would be top-notch qualities to possess.
All right. Thank you so much for such insight. Now, coming back to the application of these technologies in Africa, because that's pretty much what this podcast is centered around, how we can tell the potential of these technologies for developing countries in Africa. How do you think ML can best help Nigeria improve or any developing country whatsoever in Africa? And how do you think these countries can leverage the technology for improving various sectors? In your opinion?
Right. So I think it's one of those convoluted answers. Usually I say that we missed out on the Industrial Revolution as a continent, but we shouldn't miss out on the service economy. So the world has moved to a service economy. And if you look at the majority of the companies that have the highest capitalization in the world are technology companies. So companies like Google, Facebook, Amazon, they're technology companies. They're service-oriented companies. What that means is that they just provide service to the rest of the world. They don't ship products back and forth. Mm-hmm. So as a continent, we also need to build those services. Now, in order to scale out those services, again, we have alternatives. So it's always important to point out what the alternatives are. Do you always need machine learning? The answer is no, right? Case in point, those X-rays could actually be analyzed by specialists. You don't need machine learning to analyze the X-rays. So what is the benefit that machine learning brings to the table? It's really about scale. Again, if you, for instance, wanted to predict whether you have disease on farmlands, because we're majorly an agrarian society, you could take photographs of those farmlands, send emails to specialists who are sitting down in some rooms who will look and then say, yes, I think that there's something here, or no, I do not think that there's something here. And a lot of the time with individuals, you need a second opinion. When you apply technology, so not just machine learning, but technology, which might or might not utilize machine learning, you're then able to scale up the rate at which you provide the service. So Africa moving to a service-oriented, let's say, economy would benefit a lot, from that move. We would be able to leapfrog a lot of the challenges that we have, and get to the next point. So you could have use cases where you need to use machine learning. The truth is, machine learning is not for every situation. In the same vein that antibiotics are not the solution in every medical problem, right? Sometimes what you need is paracetamol. Sometimes what you need is vitamins. Sometimes what you need is just food, right? So it's not always the case that we need machine learning, but if you do need machine learning, if you implement it, then you're going to have tremendous benefits.
Thank you so much. Now, okay, back to you, of course, talking about the technologies the country can leverage and the future of technology, in fact, not just the present. For you, what are you excited about in the future of machine learning and AI? Do you see any technology you're excited about that interests you, that you think might also be applicable, might have tremendous applicability in African countries? What are you excited about?
So I think that, just the basic machine learning has a lot of potential. Not even looking at the more advanced applications. Computer vision has really good uses. In the field of natural language, I think that the potential to implement language translation between various African languages would make for better integration. I think that as a continent, we have way too many languages, and that causes, people to always say, are you this tribe or that tribe? Because they want to know whether they can comfortably, communicate with you and exclude others. So the fact that we have 1,000 languages means that we see ourselves as 1,000 different individuals versus, other places where, people see themselves speaking one language, even if there are a few dialects, but they see themselves as being unified. So I think that natural language technologies could help with unifying the continent by making it possible for us to communicate with people regardless of their location on the continent.
Awesome. Natural language processing, I think, is one that listeners should keep an eye on, the space of NLP. And awesome. Thank you so much. So back to advising people who are starting out or already in the field of data science and machine learning. What would be your advice to ML engineers in Africa, developing countries, Nigeria, Rwanda, and all of these developing countries? What would be your advice to ML engineers, data scientists looking for data science job in that job search space? What would be your advice there?
Okay, so my advice, and so this is not, I take this with a grain of salt, but I see a lot of job openings on LinkedIn, and I think that people need to learn to present themselves. Presentation is key. In the past, all you needed was a CV, but then a CV is a passive document. What it means is you need to get the email addresses of people and send out your CVs to them. Now we have LinkedIn. We have companies posting job openings. We have recruiters actively looking through LinkedIn, looking for data scientists or machine learning engineers and things like that. So you need to package yourself properly. You need to have a portfolio. You need to do projects. These could be academic projects, but you need to get involved. And whatever project you do, you need to document it. You need to do a post, a LinkedIn post that says, I worked on this project. This was the problem statement. This was my methodology in solving it. This is the result that I arrived at the end of the day. There's a projects section on LinkedIn that people should make use of. as well as other sections in LinkedIn. You should go in and polish your section, your LinkedIn profile. Put your best foot forward. Make it possible for recruiters to discover you on LinkedIn and initiate a conversation with you. So there are a lot of potentials, but people are just not presenting themselves in a way where they get approached.
Wow, awesome. But on your end, do you have any specific resource you can recommend for people looking to follow a path to making their LinkedIn profile presentable and search engine optimized?
So there are a lot of resources actually. Okay. What I tell people to do is just type optimized LinkedIn profile into their favorite search engine, whatever that is. Mm-hmm. And they will get some top posts, and all they have to do is follow the advice. It's surprisingly simple yet detailed, and they will be sure to see the results.
Okay, awesome. So we're leaving the job search space now, and say they finally probably gotten to meet a recruiter or connect with an employer, potential employer. Do you generally have tips for them for preparing for interviews? Especially for prime spaces in Africa like this, or maybe not just Africa, abroad and anything. Any tips for preparing for interviews?
So I would say that people have to be themselves, but they also have to be prepared. Do not put yourself out there if your knowledge isn't deep enough, is how I should put it. So a lot of the time, I understand that in Africa, we need to put food on the table and stuff. And unfortunately, sometimes people think, there aren't jobs in medicine or in mechanical engineering or civil engineering. So let me just fall back on this IT thing. But it's very easy for interviewers to see through you in 5 or 10 minutes. I mean, even for me, with all the experience I have, I mean, I've had some people interview me and I've had some nasty experiences. Sometimes I think that their expectations were not properly aligned. But the bottom line is, if you're not ready, don't go for an interview, because you're going to be hammered, you're going to be battered, you're going to come away, feeling like you haven't done anything. So do not do data science for 3 months and then start trying to get a job. I think that's what I would advise, because I've seen people do that. Yeah, people saying, okay, so if I start data science now, can I get a job in 6 months? And I say, if you met a medical doctor who was 6 months into medical school, would you let him do any form of diagnosis on you? Would you go and buy any medicine that the person prescribes? Right? Or if you go on a plane and they said this person is 3 months into piloting school, would you let him pick up? Will you? So in the same vein, data science is not a joke. A lot of the spaces where data science is applied, it's very serious. Even if you look at the less serious ones like finance, wrong decisions in finance will cost the bank a lot of money, right? But then we also have data scientists in the medical field, in some other technology fields. So it's not a joke. And so recruiters don't take it as a joke, or interviewers don't take it as a joke. And you also need to be extremely serious if you're going into the field. Otherwise, you'll just come out and say there are no jobs, and then other people are being inundated with job offers and interviews and other things.
Awesome. Very, very perfect. In fact, the perfect analogy for that. In fact, data science is not a joke. Thank you so much for that insight, Robert. So going back to more generally your advice to the audience, because I know for sure that the space of AI and data science is a rapidly evolving space. There's like papers almost every now and then, every week. There's a new model coming out. There's a new technology, new technique, and everything coming out. So how do you manage to keep track of, the progress in the space? Do you have any relevant resources, or you have any, system you have developed to help you keep track of the latest happenings and advancements in the space?
Yes. So to start with, I do not try to keep an eye on everything. In the same vein that a dentist is not trying to keep track of the latest advances in heart health, or in skeletal health. It's a vast field. However, you can keep an eye on resources where papers get published. There's a resource called Archive where a lot of papers get published. They have Twitter handles, and you can track whichever one of the Twitter handles you're interested in. And so you'll see them push a tweet when a new paper comes up with, a brief synopsis of what the paper is about. If you're interested in it, you can go in and read the paper. You can also subscribe to some newsletters. So some people will curate very specific things that they keep an eye on. And so they'll help you summarize, and it could come in maybe once a month or something. And, you can then see, okay, over the last month, ABC happened. And if you're interested, then you go in and read.
Wow, that's a really good take. Archives, we're going to be linking to that in the description. Twitter, most of the guests that come on our show, they've always talked about Twitter being a very, very specific area they get to keep track, and also very specifically keeping track. Just to reiterate the point. All right. So on the very last note, there's a very, very key question that we ask guests on our show, and this is just an advice to begin with. So what is one golden advice? We call it golden because it could be one word or one sentence, just keeping it short pretty much. What is one golden advice you would give to beginners looking to become world-class machine learning engineers, data scientists, or generally problem solvers in Africa? What's one golden advice?
It's a marathon. It's not a sprint.
Yeah.
Yeah. So, again, it goes back to, when people say, as a beginner, you then ask, how long before I become an expert? And do not look at how long before you become an expert. If you're getting in and it's a field that you like, then be prepared to stay in that field for a very long time. So if you're getting in, are you ready to work for the next 10 or 15 years, or maybe even for the rest of your life as a machine learning engineer? If the answer is yes, then get in, get there, and do it. I mean, I've been there, like I said, for about 2 decades, and I'm still doing the job. Right? So it's a marathon.
It's a marathon, not a sprint. Thank you so much. That's a headline for this podcast. Thank you so much for that. So this is at the point where we come to the closure of the episode. So Robert, do you have any last words? Any general tips, advice, best practices you think you can give to our listeners? We'd love to hear them now.
Yeah. So I think the parting advice would be, in data science, you need to learn in a repetitive manner. What it means is, the first time you learn something, it might not make sense. It's fine. You can come back to it later. And even if you've learned something that makes sense, after a while, after you've gone off and learned other things, when you come back, you will find that you extract additional insights from whatever it is.
Oh, perfect. Thank you so much, Robert, for your time today. We've now come to the end of this episode. Thank you so much, listeners, for tuning in today. Thank you, of course, Robert, Chief Data Scientist at Vassars. We'll have his link, a Twitter handle and LinkedIn profiles and the show notes. So you can get to connect with Robert on Twitter, on LinkedIn, wherever you can. Maybe you have specific questions for him. You can get to connect with him. And also, you can also learn from Robert's session on our YouTube channel, Getting Started with Model Deployment. We should be up by the time this podcast will be up, so you can check our YouTube channel out and learn from Robert. Robert is a very, very amazing community developer, as not just that, an amazing professional as well. Thank you so much, Robert.
All right, it's my pleasure.